Hey, welcome back, guys. I got a question for you. How do you follow Will Smith in the snow? You follow the Fresh Prince. Fresh Prince, that's good. Hey, we're going to talk about proving lines parallel today. Now, this is not too much different than what you've already been doing. In fact, it's really the same thing, only just phrasing it a little bit differently. Before, we've learned about parallel lines and lines cutting through, transversals. We've learned about alternate interior angles and alternate exterior angles and corresponding angles and all that good stuff, and how those things are equal if those lines are parallel. Well, what we're doing today is we're going to kind of work backwards. We're saying that if alternate interior angles are equal, then the lines are parallel, right? Instead of saying if the lines are parallel, then alternate interior angles are equal, right? It's just a different way to say it. But today, instead of assuming that the lines are parallel and working from there, we're going to try to make the angles equal, and then that will make the lines parallel or prove that the lines are parallel. So anyways, it's really just the same type of stuff that you've been working with. You're solving for x, you're going to solve for x, and when you do that and make the things equal, then the lines will be parallel. So we've got a problem here, and the first problem that we want to do is it's going to ask us to solve for x so that, the first thing we want to do is solve for x so that L is parallel to M. That's the first question. Find x so that L is parallel to M. And then the second question is asking if L and M are parallel, and you've solved for x, then use that same x and let's find out if P and Q are parallel, right? And the way we'll do that is we'll have to show that some of those angles that are supposed to be equal really are equal, and if they are, then P is parallel to Q. So our second question is P parallel to Q. Where we use these two vertical lines to show that, to say parallel, right? So first, we want to solve for x so that L and M are parallel. So let's see, L and M. That's these two guys right here. So I need to use those two lines and a line cutting through it to do some work. So I have a line cutting through here and here. I don't know any other information over here except for the 45. So I know that's 45, but I can get these other things maybe are 45 if they are parallel, but I don't know, so I need to prove that. Anyways, I'm solving for x, that's over here. So this is where I'm working. So I need a relationship. That's the key. You have to find a relationship, and we know a few relationships. We know that some things are equal, and we know some angles add up to 180. And so we're going to have to figure out what our relationship is here. So if I'm looking right here, this angle right here, this 3x plus 5, that's the same as this angle because vertical angles. And I know this angle is the same as this angle over here because alternate interior angles. And that would be the same as this guy here. So I know the blue guy, and then this angle is not one of these blue guys, so it's not equal. But remember, if this angle is the same as this angle, and that's a straight line, then this blue guy and this angle have to add up to 180. And this blue guy is the same as that. So basically, these two angles have to add up to 180. So there's my equation, there's my relationship, right? Find the relationship and then let's write an equation. So apparently this 3x plus 5 added to the x minus 5 is supposed to add up to 180. And then I'm solving for x. It's a good thing we did that solving equations review a little while ago, because this is exactly the type of equations that you were solving in that. Let's put our x's together. We've got 3x and x, that's 4x. Let's get our numbers together. We've got a plus 5 and a minus 5. Oh, that's nice. That's easy. 5 minus 5 is nothing. So our numbers are gone. And then that's all still equal to 180. All right, we're solving for x. Got a number next to a letter, that means times. The opposite of times is to divide, so we'll divide by 4. Do it to one side, got to do it to the other. 180 divided by 4, and the answer plops out. You can grab your calculator, maybe you know it. If not though, put in the 180 first, then divided by 4. Top divided by bottom, always top divided by bottom. Come out with our answer, x equals 45, sweet. So what we've done is we've said, as long as x equals 45, then these lines are going to be parallel. Right? Okay, so the second question was, if x is 45 then, is P and Q, are they parallel? So, right, P and Q are these lines right here. And so what I'm going to do to determine if P and Q are parallel, I'm going to look at these two lines and then the line cutting through. Now, which line should I use that cuts through? Well, I'm going to use this top one because I know something about that. I know this is 45. So this is the problem I'm working with right now in blue. I'm going to completely ignore this part down here. Here's my parallel lines. Here's my line cutting through. And if I plug in 45 here, hopefully that will show that these two lines are parallel because these numbers are what they should be, right? And here's what they should be. Let's just check. If these two lines are parallel, then that means this is going to be 45, and this is going to be 45, and this is going to be 45, if these lines are parallel. And then I need to figure out the other stuff because apparently that's what I'm going to use here. And so let's see. Straight line, 180. So 45 and something have to add up to 180. Maybe you can just do that in your head. If you can, remember the way you're going to use your calculator is you're going to do 180 minus this guy, 45, and the leftovers will be this guy, right? So 180 minus 45, 135. We'll do that in blue here, 135, which means this is 135, which means this is 135, and this is 135, right? And that's what those numbers have to be if these lines are parallel, right? Because alternate interior angles, the 180 degree thing. So here's the trick then. We're going to take our x is 45, we're going to plug 45 in for x right here. And if it comes out to 135, yay, they're parallel. If it comes out to be something different, then these lines are not parallel, and all these things that we know about alternate interior angles being equal are not true. So here we go. I'm going to put 45 in for that x right there. That's 3. X is going to be 45 plus 5. And ideally, that should be 135. If it is, the lines are parallel. So here we go. This means times, right? So 3 times 45. And then add 5 to that. Whew. Looks like I get 140. If these are parallel, and all of this is true, that should be 135. So this proves that this is not true. P is not parallel to Q when L is parallel to N, and solving for that X. So that's what you're going to be playing around with today. You're just going to be solving for X. You're going to look for relationships. Remember, we have 2 relationships. Either the 2 angles are equal, this equals that, and solve for X, or they're going to add up to 180. This plus this equals 180. Get your X's together, numbers to the other side, solve for X. You're just solving for X. You're doing it in the context of proving if the lines are parallel or not, but you're still solving for X. So shouldn't be too bad. Again, you've had some practice doing this already. It's just a different way to look at it today. I think you'll do fine. Good luck with the assignment today.